morning students, welcome to the next session on functions. So today we are going to discuss about recursion. So in C, a function can calls itself. In this case, the function is said to be recursive. Function calls itself. Coming to the definition of recursion, so a function that calls itself repeatedly until a specified condition is met. Function that calls itself repeatedly until a specified condition is met is known as recursive function, and the process of calling function itself is known as recursion. So recursion is nothing but the function calls itself repeatedly until a specified condition is met. That is known as recursive function, and the process of calling the function is known as recursion. Process of calling the function is known as recursion. So this is the syntax for the recursive function. Recursive function syntax. So return type, function name. Return type, function name. So the function calls itself. So inside a function, we have a function call with the same name. Function call with the same. That we call it as function calls itself. Function calls itself. So function is, here the function is recursion. That function calls recursion function. So that is, so function calls itself. So the recursive functions can be written like this, right? So in the main we are calling recursion, the function. So the function calls itself repeatedly until a specified condition is met. So this is the syntax for recursive function. For example, factorial of a given number. If you want to find a factorial of a given number using iterative definition, factorial of n will be calculated as C. So if n is equal to 0, it is 1. Otherwise, if n value is greater than 0, it can be calculated as n into n minus 1 into n minus 2 and so on, 1. See, for example, factorial of 4. Factorial of 4. It is calculated as 4 into 2 into 3 into 1, or 1 into 2 into 3 into 4, right? So whenever n value is 0, so its factorial is 1. Suppose factorial of 0 will be 1, right? So if n value is 0, factorial is 1. If n value is greater than 0, then it is also n into n minus 1 into n minus 2, like. So that is iterative definition. Coming to the recursive definition, so factorial of n will be calculated as C. So if n is equal to 0, its value is 1. If n is greater than 0, see, factorial of 4 is equal to 4 into factorial of 3. Right? So factorial of 3 into factorial of 2 and so on. See, here in general case, it can be written as n into factorial of n minus 1. If n value is greater than 0, n into factorial of n minus 1. Coming to if n is equal to 0, it is 1. So that is the base case. Base case is used for stopping the calling of the function. General case. So general case will be repeatedly executed. So it will be repeatedly executed. So there are two cases for the recursive function. One is the base case, another one is general case. See, for example, factorial of 3 will be calculated as 3 into factorial of 2. This is a general case. Now factorial of 2 will be called. Factorial of 2 is equal to 2 into factorial of 1. Now factorial of 1 will be recursively called. So 1 into factorial of 0. Now factorial of 0 will be recursively called. It is 1. Now calculate factorial of 1 equal to 1 into factorial of 0. Factorial of 0 value is 1. Now 1 into 1 is 1. Now factorial of 2 will be calculated as 2 into factorial of 1. Factorial of 1 value is 1, it is 2. Now factorial of 3 will be calculated as 3 into factorial of 2. Factorial of 2 value is 2. 3 into 2 is 6. So in this way, it is to be computed in the recursion. Now write a C program to find the factorial of a given number using recursion. Right. First write the header files #include stdio.h. Then declare the function. So factorial int factorial of int. Yeah. So this is function declaration. This is function declaration. Right. Next, coming to the main. Into main. To find factorial of a given number, first you declare n. Right. So f. So first read n value. Enter value for n. Enter value for read it. Scanf %d ampersand n. So after reading n value, call it. So f equal to factorial of n. Factorial of n. After that, print the result. So factorial is equal to %d. This is f value. Yes. So this is the main. Now write the recursive function. Write the recursive function. So int. Write the recursive function for factorial. Recursive function for factorial. Right? Int. Function name is factorial of int n. So we have base case and general case. See, already seen base case and general case. Here factorial of n equal to 1. If n equal to 0, that is the base case. So first write the, if n is equal to 0, return 1. If n is equal to 0, return 1. If n is equal to 0, return 1. Else, write the general case here. So what is the general case? See this. General case is n into factorial of n minus 1. General case is n into factorial of n minus 1. Right. Else return n into factorial of n minus 1. Yes. So this is the recursive function. So here the first one is base case, second one is the general case. So based on the base case and general case, we can write the recursive function. The recursive function must be in the recursive form. Recursive form means function calls itself. So here the function name is factorial. Inside the function definition, we have a call with the function name factorial. So then only we say that it is recursive function. So it is having base case and general case. So this is the base case and this is the general case. Right? For any recursive function, it is having two cases. One is base case, another one is general case. So general case will be repeatedly executed. Whereas base case will be whenever the base case is executed, so the function terminates. The function execution terminates. So whenever the base case satisfies, the function execution terminates. So whenever the general case will be repeatedly executed. So these are the two cases. Now coming to the execution. So first, so execution begins at the main. So it will print enter value for n. So printf is executed and enter value for n. Suppose n value is 4. N value is 4. So that is cancelled. N value is 4. Now f equal to factorial of n. Factorial of n will be called. Now the control moves to the definition of the recursive function. So here n receives the value 4. N receives the value 4. Right? So this function will be calculated. Finally, the result will be factorial equal to 24. How it will be evaluated, I will tell you now. See first 4. So first it will check the condition. If n is equal to 0, condition is false. Condition false. Then else will be executed. Then it return n into factorial of n minus 1. See. So factorial of 4 is equal to n. 4 into factorial of 3. Now factorial of this one. Factorial of 3 will be called. Factorial of 3 will be called. Now the factorial of 3 will be called. So factorial of 3. So now n value is 3. So this condition is false, else return n into factorial of n minus 1. That means 3 into factorial of 2. 3 minus 1 means 2. Now factorial of 2 will be called, recursively called. Now n value is 2. N value is 2. Now, so this condition is false, else case will be executed. N value is 2 into factorial of 2 minus 1. It is 1. Right? Next, factorial of 1 will be called. Factorial of 1 will be recursively called. Factorial of 1. Now n value is 1. Factorial of n value is 1. Condition false. So general case will be executed. So n value is 1. 1 into factorial of 0. Factorial of 0. Now factorial of 0 will be recursively called. Now n value is 0. N value is 0. So base case is satisfied. N is equal to 0. Then it returns 1. Now it is 4 into 3 into 2 into 1 into. So factorial of 0 value is 1. So finally we get 24. So this is the way the recursive function will be executed. So you try these two programs using recursion. So first one is write a C program to find the GCD of two numbers. GCD of two numbers. Second one is write a C program to find the sum of n natural numbers using recursion. These two programs you will try. Next, differences between iteration and recursion. Differences between iteration and recursion. So you know for loop, while loop, do while loop. This follows the iteration, right? So for repeated execution, we are using iteration and recursion. So when we are using looping statements, so they are iterated, and another one is recursion. So iteration explicitly uses repetition structure for I equal to 1, I less than or equal to n, I plus plus. So we are explicitly giving that repetition structure with the help of initialization, testing condition and updation. So whereas in case of recursion, it achieves the repetition by calling the same function repeatedly. So in case of iteration, the repetition structure is explicitly specified. In case of recursion, so the repetition structure is implicitly specified. So that can be taken by calling the same function repeatedly. So iteration is terminated when the loop condition fails. You know, for loop, for example, for loop. So when the for loop is executed, suppose for I equal to 1, I less than or equal to 4, I plus plus. So this loop will be executed as long as this condition is true. Whenever this condition fails, so it will terminate. So iteration is terminated when the loop condition fails. When this condition fails, the loop will be terminated. So this loop will be repeated 4 times because I value is 1 to 4. It is true. I is 1, 1 less than or equal to 4. So first time, I value 2. Second time, I value 3, I value 4. Whenever the I value is 5, condition fails, then the iteration will be terminated. So coming to the recursion is terminated when the base case is satisfied. So in the previous example we seen if n is equal to 0, whenever the n value is 0, so immediately it is terminated. So recursion is terminated when the base case is satisfied. Iteration is terminated when the loop condition fails. So iteration may have infinite loop. Iteration may have infinite loop if the loop condition never fails. If the loop condition never fails, so iteration will be getting into the infinite loop. So in case of recursion is infinite if there is no base case or if base case never reaches. Suppose if there is no base case, then so recursive function is infinite. So it is executed infinite number of times. Or if the base case never reaches, in that situation also recursion is going into the infinite situation. So next, iterative functions execute much faster and occupies less memory space. Iterative functions execute much faster and occupy less memory space, whereas the recursive functions are slow compared to the iterative ones, and also it occupies more memory space. More memory space is occupied compared to the iterative functions. So iterative functions are faster and occupies less space. Coming to the recursive functions, they are slower and also occupies more memory space compared to the iteration. So these are the differences between iteration and recursion.